Hi, I'm Craig and this is the second video in this series about the solar system, and today I'm going to talk about the sun. I'm going to talk about the sun. How big is the sun? From the centre to the surface it is 695,508 kilometres from the centre to the surface. That is 432,168 miles from the centre to the surface. The sun contains 99.68% of the entire mass in the solar system, and the sun could contain 1.3 million Earths. The sun could contain 1.3 million Earths. So our planet Earth, 1.3 million Earth could fit inside the sun. The sun is a star, and the sun is the only star within our solar system. It is an average size star, so an average. So there are some stars smaller. There are some stars smaller than the sun, and there are some stars bigger than the sun. Some stars are 1/10 the size of the sun. Some stars are 1/10 the size of the sun, so 10 stars could fit. Some stars are 700 times larger, 700 times bigger than the sun. Because of the sun's large size, because of the sun's mass and its very strong gravity, the sun is almost a perfect sphere. Almost a perfect sphere. The hottest part of the sun is the core. The core is the centre. The centre of the sun is the core. That is the hottest part of the sun. It is 15 million degrees Celsius. 15 million degrees Celsius. That is about 27 million degrees Fahrenheit. And this temperature is hot enough to sustain nuclear fusion. It's hot enough to sustain nuclear fusion. Nuclear fusion is when hydrogen atoms are fused together to create larger helium atoms. When hydrogen are fused together to create helium atoms, and this process releases a lot of energy, an extraordinary amount of energy, and in turn that produces heat and light. The energy produced at the core takes up to 1 million years to reach the surface, which is known as the convective zone. The convective zone, at which point the temperature drops from 15 million degrees to 2 million degrees. It drops from 15 million to 2 million degrees Celsius. By the time it reaches the surface of the sun, the temperature drops again to 5,973 degrees Celsius. This temperature is still hot enough to boil diamonds. So, what is the sun made of? The sun is a big ball of called gas and plasma, and 91% of it is hydrogen. 91% is hydrogen, and like I said previously, under intense heat and gravitational force, this hydrogen is fused into helium during nuclear fusion. When plasma is heated to the temperatures that are seen on the sun, it creates so much energy that this plasma can escape the sun's gravity and blow out into space. This is called solar winds. Energy blows out into space, called solar wind. When the solar wind hits the Earth's atmosphere, when it hits our planet's atmosphere, it can create auroras, such as the aurora borealis, also called northern lights. The aurora borealis can be seen the further north you are, so it can be seen from the North Pole or from places like Iceland, and this is the aurora borealis seen from Iceland. Would you like to go to Iceland to see the aurora borealis? As well as hydrogen and helium, scientists have found at least 65 other elements other than hydrogen and helium in the sun. The most abundant of these are oxygen, nitrogen, carbon, silicon, magnesium, neon, iron and sulfur. That is oxygen, nitrogen, carbon, silicon, magnesium, neon, iron, sulfur. Due to the plasma on the sun swirling around the sun rotates on its axis. It rotates on its axis, and this takes about 27 days, 27 Earth days, to rotate on its axis. It takes 30 days at the polar regions, so the North Pole and the South Pole. Yeah, it takes 30 days, and at the equator range, across the centre, it takes about 24 days. On the sun, you can see sunspots, which are these darker areas. Scientists aren't entirely sure how they are created, but they think it could be due to the magnetic field reducing radiation and cooling the sun's surface in certain spots. Solar flares are the largest and most explosive event in the entire solar system. They happen when the magnetic fields associated with the sunspots convert energy into heat and accelerate the particles out into space. They are bursts of photons or light, and they can last from a couple of minutes to several hours. The sun is currently a yellow dwarf, which is a type of star. Stars go through different phases, and the sun is currently a yellow dwarf. Just like all stars, the sun began as a contracting nebula. Nebula is just a cloud of dust and gas, and as each particle has its own gravitational pull, the dust and gas begin to form into a protostar. As this mass is pulled together, it creates heat, it generates a lot of heat. When it gets hot enough, it will start to convert hydrogen into helium through nuclear fusion, and this is how the sun was formed. This celestial object then enters its main sequence stage, during which the outward pressure, so the outward pressure of nuclear fusion, is balanced by the inward pressure of its own gravity. The Sun is currently in this stable phase. The Sun will leave this main sequence stage when all the hydrogen is burned up, all the hydrogen that's burnt off in the Sun's core. Because the Sun is a relatively small star compared to many, the outer layers of the Sun will collapse in on themselves, creating temperatures hot enough to fuse helium into carbon. At that point, the pressure will be so large, there'll be a lot of pressure, it will cause the Sun to expand, to become bigger, and it will form a red giant. For our Sun, this is expected to happen in about 5 billion years. About 5 billion years. But when it happens, it is likely to engulf Mercury, Venus, and possibly even Earth. So it will destroy these planets. It will eventually shrink back down to become a planetary nebula with a white dwarf at its centre, at the core. There are estimated to be about 1 billion galaxies in the observable universe, in the known universe. The Milky Way is our galaxy. We are in the Milky Way. We are on one of the spiral arms of the Milky Way, about here. This is known as the Orion Spur. The Milky Way galaxy is about 1 quintillion kilometres wide. That is 1 followed by 18 zeros. 1 quintillion. Okay, 1 quintillion kilometres across. This Sun and the rest of our solar system are orbiting the centre of the galaxy at around 720,000 kilometres per hour, and it takes about 230 million years to complete an orbit. Sometimes the Moon comes between the Sun and the Earth. If all three, the Moon, the Sun and the Earth, are all aligned, this can block out the Sun entirely, can completely block the Sun, and this is known as a solar eclipse. This happens even though the Sun is 400 times larger than the Moon. The Moon is 400 times closer to Earth, so they appear to be the same size, even though the Sun is much bigger. Solar eclipses happen about once every 6 months, but a total solar eclipse where the Sun is completely hidden, happen about once every 2 years. And because the Sun is extremely hot, it is very difficult to observe the Sun. We can't visit the Sun, we can't send astronauts to the Sun because it is so hot. But in 2020, the European Space Agency and NASA launched the Solar Orbiter into space. It will orbit the Sun at about 42 million kilometres, which is closer than Mercury, the closest planet. And we will talk about Mercury in the next episode. If you enjoy this video, please remember to like and subscribe and leave a comment in the comment section. And I'll see you in the next one. Bye for now.